of people here. Thanks, Jason. Cool. So this is the kickoff for the extension mechanism workstream. What I wanted to cover today is basically what this workstream is focusing on, what the expected outcome and goals are, and sort of give a bit of background about what this actual problem is. And this is one of the, in my opinion, one of the more straightforward work streams that we've got out of the four that we've come up with. So what is this work stream? It is how the cluster API interacts with cluster API providers, and namely how the cluster API providers can define the data they need to create clusters in that provider. So if you look at AWS, we use CRDs to define the AWS provider configs. That's not necessarily the only solution. There are other solutions, and there are upsides and downsides for each of these things. And what we're trying to produce is a proposal for how cluster API and cluster API providers should interact, and why we choose a particular provider over some other provider, or why we choose some mechanism over some other mechanism. And what we have today is we use the runtime raw extension embedded in the cluster API type. I've got a couple links here that you can take a look and see what those are. And we satisfy that with custom CRDs in each of the providers. I haven't looked at all the providers, but that's at least what we do with AWS, and I believe the other common ones, Google and VMware as well. So there are a couple of problems with the CRD mechanism.
Chuck, before you do, can I ask a clarifying question? You
Sure
describe it as a CRD, but that type is not registered as a CRD in the Kubernetes API, as I understand it, right? It is only inside of the cluster API provider.
Well, so it might be my lack of understanding of exactly how the mechanism works. Are you saying that we are not registering it with the API server?
I thought we weren't. Are we?
So most of the providers actually do register it with the API server. That said, they don't have to, and we aren't actually leveraging it as a CRD. We just have that in place because we're using controller runtime and controller tools to do the generation for the API server machinery that we're using for the serialization and deserialization.
Okay, cool. That sets us up. I think that's a tool in our arsenal which we can hold for later. Thank you.
So I guess I assumed that we were defining it, because if you don't define it, would things like kube control get clusters work?
Yes, they would, because
they would. Okay.
Yeah, that's part of the reason why it's a raw runtime extension, because the cluster object has no idea about the embedded type. The only time we're dealing with that is when we're deserializing and serializing it in the providers themselves today. Yeah.
I see. Great. So I can talk about at least the problems that we currently have with the existing approach. One problem that we have that actually clashes with some of the use cases for cluster API is that we can't actually determine what providers are running and installed automatically. We actually have to go and see, which controllers are running, and then hope that they're named properly and give us a way to figure out what's actually running and what providers are available to us. There really is no type safety upon cluster machine create, because it gets read in as a series of bytes and doesn't get actually read until the provider reads the configuration. I think we can do better than that, so that we can say, we try to create a cluster and it says, hey, this provider config option isn't valid. That would be really nice. And then when we were working with that configuration in the AWS provider, it was pretty annoying to program with. There was a lot of deserializing and reserializing that happens. It's like, we programmed around it, so it's fine, but like, I also think we can do better there and have like automated tooling that will work around that for us. That being said, I think there are 3 or so other mechanisms that we've been talking about that we'd like to do a little bit more investigative work on. So there is a webhook mechanism that we could use, or perhaps a gRPC mechanism that we could use in addition to the independently, well, not in addition to, but also the CRDs that we're using today. Honestly, I don't actually know how those 2 things would work, webhook or gRPC. I haven't really looked into them at all. I would love to know like how we could leverage those things to make this work. But I think that's sort of something for the group to decide and talk about. And one of the things I would like to do here is, not necessarily at this meeting, because I'd like a lot of this work to be asynchronous, but discuss the pros and cons of each of the different approaches for our extension mechanism.
Yeah, I mean, I'm not entirely sure why we're talking about the webhook or gRPC and basically protocol level stuff. Why don't we discuss the overall kind of architecture? And I mean, that seems like potential means of achieving a thing, but it could be achieve just about anything. And I don't know what is it.
So part of the reason why we broke up the work streams, Ilya, was to avoid having too many kind of tangential rabbit hole discussions as we talk about the greater project. So part of the idea of scoping down the extension mechanism is to allow that rabbit hole of how do we actually extend it to be focused here, while we talk about how do we change up the data model in a separate meeting. So that would determine more where the extension points are versus this meeting now. So that's kind of why we broke those up a little bit.
Yeah, and also
in the past, it's really gotten really confusing when we started going down some of these tangents in the general meetings. Sorry, Jeff.
And also, yeah, these exact, webhooks and gRPC are not like things that we've settled on, right? These are just examples of things we could potentially use. I think it might make sense to look at the use cases and see exactly what we outlined we want from Cluster API, and see, sort of reconcile the use cases with various ways that we could achieve an extension mechanism, and sort of build a pros and cons list that way.
I don't really see the benefit of having hooks and gRPC extensions, because if our goal is to maximize code reuse, then that's just another handler that has to be built into every single provider type. So it doesn't make sense to have a reconciliation loop at the very top level of Cluster API just to implement another control loop in a whole nother provider. So I think a better model would be to put the reconciliation loop on the provider level itself, and then we don't have to worry about what the actual implementation is for extensions. I like this transparent provider spec, opaque provider spec that we have now. I think that's probably the best model.
So I think there are benefits of not going the independently reconciled route, because if you do go the independently reconciled route, your actual status tends to stay very deeply buried in the tree. I think the webhook or gRPC model potentially provides a better benefit for bubbling common status up compared to kind of the independent CRD model.
Do we know of any examples that are using, for extensions that are using webhooks or gRPC? That's something that I would like to look at to just sort of get a better understanding of how that would work exactly. Although it looks like we do have a proposal up for gRPC.
So there's a gap, it's like a cap that Gardner put out. They're looking at using gRPC as well. I see Ardix on the line if he wants to.
Yes, so at Gardner with Machine Controller Manager, we were also in a similar phase some time back, and we implemented the out-of-tree support or the extension mechanism using the gRPC. So to describe, I posted a link in meeting notes, but the higher level idea was in a way that the extension actuator that becomes basically a gRPC server, and it has a very minimal responsibility. It has basically three main methods inside it: create machine, delete machine, and list machines. And the input to that method is basically the provider spec that we have. Provider spec, and then different ways of providing the secrets, but we were directly giving the secrets on the wire itself because we expected the gRPC server will run as a sidecar container. So basically, you give this provider spec to the create, delete, and list machines method, which are the gRPC services, and they internally process it. And then whatever response is required, it gives the response back to the original shared controller. And the overall benefit that we saw there was that more or less your entire machine controller is basically shared. So it's much better control over the much larger part of the code with the central repository, because I think we will also start seeing the pattern where all of us have a very good eyes on the central project, which is the cluster API project. We somehow make sure a lot of things, but if there are more responsibility going in other projects, then we will have to think twice that what kind of responsibilities should be taken care at that point. So because the entire machine controller is shared at one place, it gives us the benefit of controlling the framework better. Then a couple of other things is like vendoring. So one thing that we are doing with the current machine controller approach is we are more or less vendoring the entire cluster API project inside it. So we want any very small part of it to be used, right? And at some point, I guess it becomes, it's not now, probably it can become a little bit of a burden that you basically have to keep track, or at least you want to fairly be compatible with the upstream cluster API project, and you have to keep re-vendoring and make sure that you are up to date with the vendor machine controller. So those were the kind of benefits we saw, and we did implement with the gRPC. I can share a link, the driver that we have. You can probably have a look on it.
Yeah, so one of the things that I was thinking, instead of getting too deep into any of the implementations in this meeting, we could start a document where we describe kind of the different proposed approaches that have been proposed so far, potentially introduce newly proposed approaches, and then we can start detailing some of the different pros and cons associated with the different approaches. The other thing that I want to say too is that since we are talking about breaking things up a bit and having, say, differences between infrastructure providers and like cluster bootstrapping providers and things like that, there doesn't necessarily need to be a decision made on one specific extension mechanism. It may be that different types of extension mechanisms may make sense for different use cases as we continue to build out as well.
Yeah, I started a document for the proposal, for the various proposals. I'll post that in the channel in a little bit.
So another example of the gRPC approach, I believe that CSI uses gRPC for their plugin models.
Okay.
Yes, that's correct. So we have basically replicated almost everything from the CSI model, how the way they are managing projects and so on. And I think that's the reason Said Ali also probably commented on the proposal. So yeah, just wanted to convey that yes, they are also using gRPC.
So I think I agree with Jason that we don't need to, we should have go into the detail of the proposal, but I don't still have clear idea of what problem we want to solve, because we start talking about, for instance, this problem of having the this opaque data inside of the cluster API and passing it to the provider. But probably we could summarize 3 or 4 objectives, something we agree we would like this to happen. For instance, for me, something that I dislike about this approach is that it's not obvious what providers are installed there, or which, if we have more than one, because everything is inside. I mean, there's a lack of this opacity of this is something I disagree. So that's the kind of thing I would like to, probably it's easier just to start as saying, because then we can compare solution against that common goals.
Yeah, and that's kind of the goal of the use case document, to sort of be able to take a look at what use cases each different extension mechanism may or may not provide.
So should we brainstorm some goals right now?
We sure can. Yeah, that's fine with me.
So one goal, and I don't know how to phrase this, but I'd say we would like to enable out-of-tree development, but moreover, we'd like to make out-of-tree development easy. The easy part's kind of hard to quantify because when you think of solutions, and I don't want to get into solutions, right? But you could use like the add-ons as operator mechanism where you generate operators, right? Maybe that makes it easier. Another mechanism would be webhooks. Another one would be gRPC. And then when comparing those, we can compare them against our goals. All three of those allow out-of-tree development. Mm-hmm. So then we would have to talk about, well, how do you distinguish between the mechanisms that provide out-of-tree development? Maybe there's no way, or maybe one way's easier or more familiar to others. I think that would be an important benefit, especially for the bare metal case because of the variety of different implementations that
I think at the moment people are already doing out-of-tree providers. I mean, all of the providers are kind of out-of-tree, but as far as I could tell, but they're somehow in lockstep with the tree. So I think basically kind of decoupling providers from what is upstream would probably be more helpful there. Like I think that's the kind of bit we're talking about really, because at the moment like they are in different repos, right? There's the kind of the general bits in the cluster API projects, and the providers are in different repos. But like, how do these things relate? How do the providers relate to the top level repo, and how versions relate, and how API changes and evolution of each of the particular provider relates to that? It's kind of tricky, right? So I mean, I think that is the particular bit that we're kind of talking about here, not so much the development in the separate repo as such, because that's already happening per se.
Yeah, is that what you meant by out of tree, David?
Yeah, we are. You're right that we are currently developing out of tree. The question is, like, how much effort in total is it? Right. Last year we had a change where we went from aggregated API servers to CRDs, and that broke every provider. Right. So those kind of changes are just extremely disruptive, and I think that it would be better if we had more stable migration plan. So right now they're out of tree, but so I'm looking for the words, but we want to make it easier to develop out of tree. By the dependencies on the cluster API, perhaps.
Yeah, and there are other issues with the way that we build and deploy today, because we have to vendor the cluster API controllers for the machine and the cluster, and we end up deploying providers along. We end up deploying the provider CRDs along with the common CRDs, and it creates a really easy way to, if you try to deploy multiple providers, of breaking one or more of the deployed providers based on whichever last version of the CRDs are deployed. So breaking that requirement to vendor and tightly couple the deployment between the common code and the providers would really ease the kind of maintenance of deploying multiple providers compared to today.
And it seems plausible to suggest that generally both the upstream API definitions and each of the providers should be able to evolve at their own pace, right? So if certain provider wants to do something that doesn't yet exist in the main repo or whatever, they should be able to kind of accomplish that somehow. And similarly, the other way around, the kind of the upstream bit should be able to evolve and move ahead while the providers are still catching up.
Also, I don't know, it's probably related, but I remember, Jason, when in some time ago with the cows, I think it was you that you wrote the point that, for instance, personally, we need to have a per provider binary for the cluster CTL, because, and that's something that is not manageable in the long term. It's annoying. I think that that's also something should be somehow tried to be addressed. You know, allow kind of having the common binary for the cluster CTL, probably some extension mechanism for the specific part of the provider. I was looking at the code the other day, and it's not really easy to understand how that could happen, but at least it's something that we should try to achieve.
If I can make a suggestion on the goals, I think it would be useful to see the problem in like two different spaces, like one from cluster API perspective, right? Like upstream, what do we want to offer? And the other one from downstream. So what the provider should see, so that we set the boundaries between the two conjunction point, and then this will probably help like decide which method and how do we want to continue from there. I'm saying this because I see in the goals like there's a lot of understanding. I mean, at least from my side, if we're talking about from the provider side or from cluster API.
Yeah, I think that's a good point. I don't know how much. I guess I would go back to the use cases document. Like, I don't really know how much we have been talking about sort of the because that's kind of like the user versus the developer dichotomy. So like, I don't know what we want to optimize for, like which one is more important.
I would think that these are extension mechanisms looks more like for the provider, maybe. However, some aspects like the one I mentioned before, like if I had to have a different cluster CTL for different providers, one of the objectives of the cluster API is for multiple providers. From the perspective of the user, how do you do that? I mean, how do I have 3 different CTL for different providers, all do the same, more or less? So that particular one is probably more user-facing, but
yeah,
you know, that's the one I for me is clearly user-facing. The other I look at more like provider-specific, make it easier for provider, as somebody mentioned before, being allow providers to have his own evolve in his own pace without having to be tied to the evolution of the cluster API.
I mean, maybe one way to think about it is that actually those things are somewhat interdependent, and any given provider should have equal chances to provide the best user experience they would like to provide to their users. So thereby, you know, they need to be able to do that, and I think that perhaps is a way to think about it. So both of those things are kind of important. I mean, almost equally important, but it's like from the upstream point of view, the providers should be able to, you know, should have equal chances essentially to deliver the best user experience on their end, whatever they define as users. Obviously, you know, there are some cases where things can get very complicated, but it's hard. We get into the territory where it's really too hard to generalize. But this may be a way to think about it. What people think.
I think that's true, but I think we also want to corral everyone around a usable API that works for everyone. So, for example, I'm very wary of saying that we would expect cluster API providers to support cluster API because, for example, we want a machine deployment and a machine set to operate exactly the same way, whether you're on AWS or GCP or Azure or bare metal. And we don't want that a rolling update, for example, behaves differently or doesn't work on one cloud but works correctly on another cloud because the provider has forked the implementation in some way.
I think that's an important point, and I think it's worth investigating breaking out machine set and machine deployment into their own top-level component in this space. And the cluster API should be a consumer of those items.
What would that look like differently in the code organization? Like, I feel like that's sort of what we have.
Well, you mentioned the problem is if somebody forks cluster API, you're going to get drift on those components. So the obvious implication would be a separate repository.
Yeah, I don't think that's what we want to do. One thing that we set for a goal is to reuse code and make sure that cluster API can offer as much as code to reduce duplication across providers. I don't know what we will solve like by moving out machine set or machine deployments outside of cluster API.
I mean, I think there is actually a case for splitting the cluster API repo into machine deployment, machine set, and the machine actuator, in that I think that might help people understand that, that they, when they're writing cluster API provider, my cloud, right, they have to vendor this library and they're getting all this stuff that they have to vendor this repo and they have to get all this stuff which they don't think is necessary. But, you can, as long as you don't have to use the machine actuator to write a functioning machine controller. We would like you to, and you might fall foul of conformance if you don't. But if you want to write it in Ruby or whatever it is, you can go and do that. But we do want you to continue to use the machine deployment and machine sets. So if, as Michael suggests, like if we achieve that by splitting into a different repo, then I'd be in favor of that. But at the same time, we can also sort of document that that's sort of how it is. And
yeah, this is a real problem that we're having at Red Hat today. Is we definitely want to consume as much upstream pieces as we can, but having everything in one repo, requires us to either heavily patch things to rename things into our own namespace, or we have to kind of build over top of the existing namespace. When I say namespace, I mean like project name, the Kate's IO, whatever. And it just creates, an ongoing maintenance challenge where, having everything in one large repository, is causing some of what you're talking about as far as drift.
So this is exactly why we're having a work stream around the extension mechanism is because we no longer want to have this vendor build your own controller using your own custom actuator approach. So I don't see how specifically breaking out machine set and machine deployment would accomplish anything different than we're talking about trying to build out in this meeting to provide that separation.
Because you're effectively going to remove machine, or you're proposing that we would remove machine actuator from that repo. Is that right?
Yeah, I mean, depending on what type of kind of extension mechanism we talk about, there would be like a common machine controller that is deployed with cluster API that would either call out via webhook or gRPC, or it would somehow bubble up status from an independently reconciled provider CRD that would be distinct and separate from the machine controller itself.
I don't see a lot of value in doing that because, again, we already have a control loop in the machine controller, and if we have to write a gRPC server or webhook server, that is going to be effort duplicated across every provider. And then getting that coupling and timing and everything right and making sure we're communicating the right things at the right times. And I think that's going to be a lot trickier than just, I like the library version of implementing an actuator. It feels very clean. That's where the reconciliation is happening. And I think, if it's a concern of bubbling up information to the top levels, that's an easy requirement. You can say the actuator must implement these things.
Yeah, so I think this is a good conversation. I just want to make sure that we do end up capturing these sort of thoughts because we're at the end where I think we will need, pro and con list of different approaches to this problem. So it might make sense to just sort of call it here and reconvene on a document and sort of let people add their approaches to a document and sort of discuss there.
I think that's fine. I'd also add one thing, which is it's open source. If we make a project fun, resources are infinite, and there is no need to have one solution, and we can have a gRPC approach and a controller approach and a webhook approach and a Ruby approach or whatever you want, and a WASM approach. my personal favorite, but I'm not seriously proposing that. But it's not like we have to all agree, and we can sort of see which one sticks in the long term.
Totally.
Yes, and I would completely agree on that. So we actually also did something similar. It's actually possible that you can have different. So in the same shared repository, basically you can have a separate section where you implement different kinds of clients. So we implemented one client for the gRPC. So that client's job was to talk to gRPC providers whenever required, and if gRPC is not supported, and it can still talk to the entry providers or the other kind of providers. I think that makes perfect sense to me. We don't have to really hard cut someone to do only one approach. That's one. And the second thing, which I think overall what we are missing is the adoption point of view. So I think where the way I see the CSI model, right, the way they win is because the adoption was super easy. So what do you really expect from the user or the provider implementers? That what do they really need to know if they want to bring their provider inside the stack? So we need to then decide that what minimal can we expect from them? Do we really expect them to be knowing about writing the full-fledged controllers, maintaining such controllers, or do we at what extent? So if the implementer is well aware, then probably we can give much better flexibility, where they can write their own controllers. But if there are some certainly new providers and who do not really want to know how cluster API really works internally and really want to deal with internal stuff, then probably can give other way where they can just implement simple methods and it still works for them is the way it should work. Just thinking out loud. Yeah, but we have to keep a mark on adoption as well. That how easy can we make for others?
Yeah, so it sounds like we still need to finish building out the goals and requirements that we have for this. I think some of those are still need to be fleshed out. We need to get the different kind of extension proposals fleshed out in the proposal doc as well, and then we can continue to iterate on weighing the different approaches. And I think there is some variability even with some of the approaches, because somebody mentioned earlier that they do like the kind of embedded blob that we have today for provider config, but I know that others have expressed that it's actually kind of painful having the embedded blob as well. So we need to weigh that as well, in addition to just kind of the extension mechanism itself.
I would point out that a number of implementations, including at least one from Samsung, has not used the cluster API precisely because the encoding and decoding of provider status and spec was considered onerous and with little value because there are so few required fields.
Right. Yeah, and this kind of leads to the data model, doesn't it? So I was wondering, how do we manage the interdependencies between whatever the decisions are going to be made and then the data model workstream and here? I mean, would it make sense to kind of go through the data model discussions for a couple of weeks and then reconvene here after that? Or how are we thinking about this?
I think we can keep it separate. Given that data model will treat the webhook mechanism kind of a black box, right? Like we don't know what this extension mechanism is going to look like, but we know it's there. And then when we go to kind of more implementation details, we probably gonna either not merge, but see what this work stream has done to align.
So are we going to look? Are we looking to explore all sorts of possibilities on the data model end of it? I mean, it just seems like we are getting into those discussions quite inevitably, or maybe I'm misunderstanding what do we mean by data model versus extensions and where the line is actually.
Yeah, also just to watch the recording so that we're all on the same page.
The other thing that we need to keep in mind is that not everybody that is interested in these discussions and has requirements that are driving these discussions is able to be at any one of these meetings. So the more we can collaborate on the docs and the more we can collaborate in an asynchronous fashion, the better it is. For one example, I know that we've had a lot of contributors from China recently, and they haven't been overly involved with the discussions because of limitations with access to the tools, times that we're having the meetings. So the more we can kind of drive some of these discussions into the docs and into the discourse forum, the better it is to kind of get input from those folks as well.
Yeah, and that's kind of one big goal of moving to the document and writing all this down and sharing it in the discuss thread. So I think with that, I will send out a document for us to start working on and see, if there's more work we can do here, or if, I think it will not be dependent on the data types, but not totally sure how all that work's going to go. So. If there is anything else people would like to say, feel free to now. Otherwise, we can have some 24 minutes back. Cool. Then I think Jason's going to post the recording at some point in the not so distant future, and I will send out a document for folks to type into. Thank you all for coming.